Welcome to the Eduonics Cloud course. Today we're looking at Cloud Technology Example 3. We're looking in particular at the Google Cloud Compute Engine. And we're looking at Infrastructure as a Service, Platform as a Service on Google Cloud Compute. This is a document with the title that I have just highlighted. And you can find this document in the documentation folder for this topic. Like Amazon, Google offers a range of cloud services. And there's a schema where it's easy to distinguish between infrastructure as a service options as opposed to platform as a service. So, if we look here at this diagram, it highlights their offerings. And here, we can see a clear distinction between infrastructure and platform. We look at Compute Engine and App Engine. Compute Engine allows us to construct a virtual box in the cloud. And it is clearly infrastructure as a service, whereas App Engine is purely for making applications. One clear distinction between an application created in App Engine as to an application you would create in a Compute Engine box is that in the App Engine box we have no access to the file system. So we see a clear break between infrastructure as a service offerings such as Compute Engine and platform as a service offerings such as App Engine. So what we'll do now is we'll go through every step that's required and demonstrate how to create a virtual box on Compute Engine in a Google Cloud platform. The first step in creating our virtual machine in Google Cloud Compute is to sign in to Google's Developer Console and create an application. So if you haven't already, you need to sign up for a Google account. And this is the URL that takes you to the Developer Console, and that looks like that. You select Create Project to create a project, and then you select Billing to enable billing for the project. To create a Google virtual machine in Cloud Compute, you need to enable billing. Now when you click the Create button, it will ask for SMS verification. And you need to go through the whole SMS dance. And once you've enabled for that, and you've enabled billing, you get to the point where you can now start to create a virtual machine. And we'll just take a moment to talk about the possible virtual machines that you can create. Now we'll just compare what's on offer at Google to what's on offer at OpenShift. Now in OpenShift, we were able to create free virtual boxes. Each one had approximately this much memory. See where I'm waving the mouse now? This is the cheapest machine on Google. So there is no free machine. And this machine here, which has roughly the same amount of memory, is 1.3 US cents an hour. That's an F1 micro. But it has a shared CPU, it's not guaranteed. A G1 small is the next step up, and it's 3.5 cents an hour. I've worked that out. The G1 small, 3.5 cents an hour, works out to be about $6 a week. This is US dollars. Cheapest machine, the F1 micro, which doesn't sort of guarantee CPU access, is still $2 US a week. So you compare that to the Red Hat OpenShift, where you get free boxes that are somewhere between the F1 micro and the G1 small. They have the same amount of memory as the F1 micro, where they have a bit of CPU, and they're totally free. So you can see the OpenShift is offering a really good free service, especially if you are a runtime programmer, not just an HTML programmer. So if you need a language runtime, access to the file system, create an application, You can create 3 applications on OpenShift for free, and the equivalent cost in Google would be something between 10 to 15 US a week. Now, if you don't have much money and you want to get started in the cloud, then you're really getting a leg up from Red Hat as opposed to this Google service. This Google service is still very good, but you pay for what you get. I probably should state at this time a disclaimer that I do not receive any income from Red Hat. I do not work for Red Hat. Also, to put it on the record, the Amazon EC2 free tier box is also excellent value. Now, both the Amazon free tier box and Google, even for the cheapest machine, both require you to enable billing with a credit card, whereas the Red Hat does not require a credit card. Red Hat clearly comes out on top in terms of value over both Google and Amazon. Now, what we're going to do is create a G1 small box because, in my considered opinion, the G1 small represents the best value out of all the options here. These standard boxes, you can get them with single cores and dual cores, quad cores, octo cores. And you can see they have the price increasing with the number of cores. And it gets, so the $1 an hour box is going to cost you quite a lot to run. That's going to cost a couple of hundreds of dollars a week to run a 16-core box. So what we're going to do now is go through the steps in creating this G1 small virtual machine. To create our virtual machine, we simply select the project that we have enabled billing for. That will bring up the view where we can enable cloud compute. So here, where it says spin up a compute engine, so we select Create Instance. You will probably get this message: Google Compute Engine is not ready for use yet in the project. It may take several minutes if Google Compute Engine has just been enabled. So it's going to take a while for the developer console to contact Google Cloud Compute Service and create a view in Google Cloud Compute Service for your instance. So what you do is just wait and keep refreshing the browser. And this could take 10 minutes, 15 minutes even, so you might want to go away and make some coffee, come back, keep refreshing the browser. And eventually you will see the screen below, and you select Spin Up VMs Fast. So you create an instance on the left here, and eventually you should see this screen below, and this is where we configure the virtual machine. Very similar to the Amazon EC2. So we create a new instance with a name, and we have metadata, which at this moment we can just leave blank. And for firewall, we can simply select Allow HTTP traffic. For HTTPS, then you would need to configure some sort of security certificate, and that's very difficult, so we'll leave that. You choose a location for your resource, so that's where your customers will be. So if you're in the EU like me, you would choose EU. If you are in North America, you could choose the appropriate region. Then, for the machine type, we're going to choose the G1 Small. These were the options that I chose. Here we have the options as I've chosen them. The G1 Small looks like this. And a new disk from image and delete boot disk when instance is deleted, that'll save you money because they charge you for the disk. An image type, I've chosen Debian. And the disk type, it doesn't cost you any more for an SSD disk, so that will boost performance, so you can choose that. You just choose the default settings for network and external IP. And once you've configured everything here, you click Create. After you click the Create button, you may see some confusing screens. You just need to wait for a few minutes, and eventually you should be able to find this screen below. And we'll look at this screen in my running instance. Now, you won't see any CPU activity at first. The important attributes that you need to identify are down here. I've just highlighted them in blue, and it's the external IP that's important to find. And what we're going to do now is configure SSH keys. Configure the box with that key so that we can SSH into the box with putty. Firstly, we are going to use puttygen to generate an SSH key. Then we're going to install that SSH key for the VM instance, and then we're going to use putty to SSH in. So let's carefully go through every step in that process now. We carefully went through every step for creating a key with puttygen in the Amazon EC2 segment. And we'll just go through it a bit quicker now. So the key points are that we need SSH2 RSA key. We're going to actually generate a key. So generating a key now, and it will ask you to move the mouse around a blank area so that the key can be generated. When the key is generated, it's going to pop up. So this is the actual, sometimes it's what I'm highlighting in blue here, is referred to as the key block. This part here that I'm highlighting is the protocol, and this part here is going to end up being our username for the box. The important thing is that we need to have a paraphrase. So you need to enter a paraphrase here. Just a little expression that you can remember. You can think of this paraphrase for the way we're going to use the key as being like a password. So once you enter the paraphrase, don't forget the paraphrase. Write it down if necessary. So here, in the documentation, we've highlighted the steps so that you can review. So this is the download link if you can't remember how to find puttygen or if you've lost your new box. This is what the final result looks like. And here, I've entered the paraphrase. You need to save the private key. So you select Save the Private Key. So we do not save the public key, we save the private key. We remember the name that we save the key in. So now, what we're going to do is configure the instance with that key. So we need to actually select the instance, and we go down and we see here the metadata. You select the metadata, and you can see up here there's a tab for SSH keys. So there, I have actually configured the key. So the way I do that is, I actually grab just what's in here. So this differs a little bit from Google's instructions, because if you look at Google's instructions, they are saying here, put a username and email. And it may work if you do that. But what you can do in the first instance, just to get used to the process, you just use what puttygen creates. So you copy this, you go edit, this is my first key. I can add a new key this way. So if I just copy what I copied out of puttygen, and see how this last bit here has now appeared here. If I click Done, I'll enter that new key, but I won't because I only want to have one key. And that is all that's required to configure the instance with the key. So it's not too difficult at all. So now we will SSH into the box using putty. So we need to identify the external IP. So if we go to the instance, so we select VM instance, we'll go down and we find our external IP. And this will be our host name. So we go to putty, and we're going to put our host name into putty. So we enter our external IP into putty as the host name. And we check that we got SSH. And so now what we need to do is load our key. I got it here where I'm pointed to. Here's this SSH. Choose Auth, and then choose Browse. And then we need to choose the key that we saved for. So here, this Eduonix is the one that I've created for EC2 or Amazon. So the Google one is the one I load. So I open that up, and now I go back up here. I need to go back up to the sessions. This is a key thing. I click on session. Now my key is loaded into putty. So now if I go open, and just before I do that, I just go down here to metadata, and I'll go to the SSH key step. And see this here, this value here, this is my username. This is what putty will require as my username when I log in. So now, with sessions selected, the Google public key loaded, I go open. This opens a session. It says log in as. Give it that key identifier as the login. Now it wants the paraphrase, like a password. So you give the paraphrase, and we're in. And I can go ls. So now I've SSH'd into the box. So that was a fairly painless experience. And you might need, if it doesn't work for you, you might need to go back and review each step. You might have made a little mistake somewhere. So now we have a Debian box. So let's just quickly install something on the Debian box so we can see how to work with Google Cloud Compute. Now it's a lot easier than working with Red Hat OpenShift because everything that we have here is for us. This is just a blank Debian slate. There are no environment variables that we need to learn or bind to, just as we struggled with a Red Hat OpenShift. What we will do is we'll install MongoDB. So on Amazon EC2, we installed MySQL. We have a database that's probably just as clean as MySQL, and just as important is MongoDB. Turns out there's a bug in the Google Cloud Compute Engine Debian images, so that's a good thing to know. So unless you're a newbie to Linux, you might want to try and avoid using the Debian image in the first instance. The Debian image would definitely be the easiest Linux image to use on Google Cloud Compute, so that's why I chose it. But it turns out that the build of the Debian image has this major bug. It's not too hard to fix, so we'll go through the steps. The problem is that the default locale isn't set, so what we have to do is set a default. So you copy these commands into Debian, and then you copy this one, and then this is the tricky one when we copy this one in. So I'll just show what this looks like. So I've already set this up. So I've already pasted those two in. So if I paste this one in, I get a pop-up screen. Now I need to identify the locales that I want. Now the easiest thing to do is just to select all locales. That would take a few minutes. I'll just cancel this because I've already done it. So I cancel. And this is the screen, and it takes a while. And so it will load up in the console all the regions in the world. So this just means anyone on the internet, anywhere in the world, can access your box in their language or write code for this box in their language. So now the next thing to do is to actually install Mongo. And you can just copy these instructions in. I have already done that, but I'll just show you what it looks like. So we'll just copy this one in. It just looks like that. So now you need to use sudo. It doesn't ask for a password because we're logged in as root, but it still needs sudo to work. And now we do updates. So I'll show you what the update command looks like. So now it's going to update its repositories. So in Debian, it has a repository list. And so now it's contacting all those repositories and seeking to update all the software that it has installed. So if there's any new versions, it will install the latest versions. So after that, we would then just issue this command, sudo apt-get install MongoDB. Now previously, you might find on the internet where they have this command using MongoD. But it's changed now, and you need to use MongoDB. And then you can actually start with this command. So I'll issue this command. It will tell you Mongo has already started. So you can see Mongo is already running. And now we can access the Mongo shell. Just type Mongo, and we're into Mongo. We're going to exit. Now we could write some software now where we could access our database and use our database as an online data store. This winds up our first look at Google Cloud Compute using the Google Cloud Platform for infrastructure as a service. So we'll move on to the next video now.